Look at this magnificent giant. This is Hyperion, the tallest tree in our world, standing at a breathtaking 116 meters, a true titan of nature, reaching for the heavens. But what if I told you that on another Earth, trees could exist that make Hyperion look like a sapling? Trees 1,000 times taller? Imagine a tree so tall it pierces the clouds and scrapes the very edge of space, reaching an astonishing 116 kilometers. That's 72 miles high. This isn't just a flight of fancy. It's a philosophical thought experiment that reveals the profound interconnectedness of life and environment. Our Earth, as we know it, simply can't support such gargantuan flora, and understanding why helps us appreciate the delicate balance of our own planet. So, why can't trees grow that tall here? First, let's talk about water. Every leaf on a tree needs water, right? Trees pull water from their roots all the way up to their highest leaves, like sipping through an incredibly long, thin straw. This amazing process relies on two things: water molecules sticking to each other, what we call cohesion, and sticking to the inside of the straw, which is adhesion. It's a continuous column of water. But here's the catch. Gravity is constantly pulling that water back down. The taller the tree, the harder it is to defy gravity. Eventually, tiny air bubbles, like kinks in our straw, can form, breaking the water column and starving the top of the tree. This is the ultimate height limiter, putting a cap on trees around 120 to 130 meters. It's a cosmic thirst that even the mightiest tree cannot overcome on our Earth. Then there's the sheer weight. Imagine a tree, 72 miles high. The wood itself would need to be unbelievably strong to not buckle, bend, or snap under its own immense mass. Even a gentle breeze would become a hurricane-force gale against such a colossal structure. It's like trying to build a skyscraper out of spaghetti. It just wouldn't hold up. And what about feeding this giant? Getting nutrients from the soil all the way up to those distant leaves would be a monumental task. Plus, a tree needs energy to grow and maintain itself. While the leaves at the top are making food through photosynthesis, the energy cost of simply existing, transporting resources, and holding itself up would become astronomical. It's a cosmic budget problem. At some point, the tree spends more energy than it takes in. So, for trees to reach such impossible heights, our Earth would need to be fundamentally different. It would be a truly alien world. The single most crucial change? Much, much lower gravity. If gravity were weaker, pulling water up would be easier, and the tree's own weight wouldn't be such a crushing burden. On a low-gravity world, trees could just keep growing, unburdened by the relentless pull we experience. Think of it like a feather floating in the air. It barely feels the pull. Next, imagine an incredibly dense atmosphere, rich with carbon dioxide. This dense air would help support the tree structurally, almost like water supports a boat. And that extra CO2? It's tree food. A CO2-rich atmosphere would supercharge photosynthesis, giving these giants the energy they need to grow to unimaginable sizes. It's like giving a plant a constant, infinite buffet. And the air itself would be perpetually thick with moisture, almost like a constant fog. This high humidity would reduce the amount of water the tree loses through its leaves, making water transport far more efficient. No strong winds either, just calm, still air. So these towering structures aren't constantly battered. Finally, imagine soil so rich it's almost alive, constantly replenishing nutrients, and even then, these trees would likely need to evolve entirely new biological tricks, perhaps super efficient vascular systems or internal support structures we can't even dream of. Now, if a planet had these conditions, what about its creatures? Would they be giants too? Absolutely. Lower gravity would mean land animals wouldn't need super strong bones and muscles just to stand up. Dinosaurs would look like house pets. Imagine creatures with unbelievably long limbs, their bodies lighter than air, able to grow to sizes that defy our imagination. And flight? It would be a breeze. With less gravity pulling them down and a denser atmosphere providing more lift, flying creatures could evolve to truly monstrous proportions. We're talking about flying beasts that could blot out the sun, far bigger than any pterosaur or bird that ever existed on our Earth. It's a world where the sky is truly open for giants. Even insects could become enormous. If that dense atmosphere also had more oxygen, their simple breathing systems would become incredibly efficient, allowing them to grow to sizes that would make our biggest bugs look like specks. Here's a plot twist. Thanks to that super thick, dense atmosphere, direct sunlight would have a harder time reaching the ground. So, forget about sunbathing, unless you're a fan of the world's dimmest tanning salon. The atmosphere would scatter and absorb most of the sun's energy, acting like nature's own pair of sunglasses. Plus, it's a great way to dodge those pesky, harmful rays. Living here would feel like you're stuck in a never-ending twilight. Perfect for anyone who thinks daylight is overrated, or just wants to sleep in forever under those 72-mile-high trees. But don't get too cozy. This dense atmosphere, especially with all that carbon dioxide, would trap heat like a greenhouse on overdrive. It's basically the planet's way of turning up the thermostat. So, while the sunlight might be dim, you'd still be sweating it out in a world that's warm, misty, and just a little bit mysterious, like a sauna with a really dramatic lighting designer. Now, for the philosophical kicker. What if this incredible world, with its mile-high trees and colossal beasts, suddenly reverted to our Earth's conditions? What if gravity suddenly increased, the atmosphere thinned, and the humidity vanished? These magnificent creatures would face instant, catastrophic death. Their bodies, evolved for low gravity, would simply shatter under the immense, sudden increase in weight. Their bones, their muscles, designed for lightness, would fail instantly. Their hearts and circulatory systems, adapted to pump blood with minimal effort, wouldn't be able to cope. Blood would pool, unable to reach their brains, leading to rapid organ failure and death. And their respiratory systems, accustomed to a dense, oxygen-rich atmosphere, would gasp for air in our thinner one, quickly succumbing to suffocation. It's not just a struggle, it's an immediate, total system failure. And what about us humans? If we were born and evolved on that low-gravity, dense atmosphere world, could we slowly adapt to Earth's conditions? The answer, shockingly, is a resounding no, not without a miracle. So, biological adaptation happens over hundreds of thousands, even millions of years, through countless generations. Our bodies are, perfectly tuned to our Earth's gravity and atmosphere. A human from that giant world would be physiologically incapable of surviving here. Their bones would be too weak, their muscles too atrophied, their hearts just way too feeble. Stepping onto our Earth would be, honestly, an immediate death sentence. There would be no time for slow adaptation, because, really, the initial shock would be instantly fatal for virtually every individual. The only way a handful might survive such a drastic, sudden change would be through extreme technological intervention, like living in self-contained habitats that perfectly replicate their original environment, or wearing advanced exoskeletons that literally hold their bodies together and provide a breathable atmosphere. It's not biological adaptation, it's technological defiance of a fundamentally hostile world. This thought experiment isn't just about giant trees or impossible creatures. It's actually a profound reminder of how intricately linked life is to its environment. Every living thing, from the smallest microbe to the tallest tree, is a masterpiece of adaptation, shaped by the fundamental forces of its world. And it really underscores the incredible fragility of life when those delicate balances are disrupted. Our Earth, with its specific gravity, atmosphere, and conditions, isn't just a backdrop. It's an active participant in defining what life can be. And in that, there's a deep philosophical beauty. The beauty of perfect harmony between life and its unique cosmic home. What if? If you enjoyed this video, don't forget to like, subscribe, and share it with your friends. Thanks for watching.